Hello everyone, in this video we are going to see about the non-linear data structures, trees and the graphs. Let us see first of all the graph, the definition of a graph. A graph is a collection of two sets V and E, where V is a finite non-empty set of vertices and E is a finite non-empty set of edges. That means the set of vertices and edges where both should be non-empty. That means there must be some vertices and there should be some edges. That is the graph, the collection of vertices and edges. Vertices are nothing but the nodes in the graph. So we have in the graph nodes are there and the nodes are connected by lines. They are called as an edges. Two adjacent vertices are joined by the edges. Any graph is denoted by G, that is a capital G, is equal to set of all V and E. So V are the vertices and E are the edges. Let us see an example graph here. So this is one graph having the vertices. This 0, 1, 2, 3, 4 are the vertices. And the line joining this 0 to 1, 1 to 2, 2 to 3, 1, 2, 3, all are called as an edges. So we can say that G is a collection of set of all vertices V1, V2, V3, V4, V5, etc. Like and finite. We should say it is an finite. So we should have finite number of elements. So the graph is finite. That means limited number of edges and limited number of vertices will be there. So it is a limited set of vertices and edges and they are non-empty. Let us see then what is a tree. A tree is a finite set of one or more nodes such that there is a specially designated node called the root. Here we have a special node called the root and from the root there will be many subtrees. So the remaining nodes are partitioned into n greater than or equal to 0 disjoint sets T1, T2, T3 etc. up to Tn. That means we have a node and from the node there are many trees and all the trees are disjoint. That means they are independent of each other. Where T1, T2, T3 they are called as an subtrees of the root. So this is the example of a tree. Here the node 1 is the root of the tree and this is the branch, one branch of the tree. And then this is the another branch and we have so many subtrees. So but there will be one designated node called the root. This is an hierarchical data structure or a non-linear data structure. Actually what is non-linear is in the case of stacks, queues, arrays and linked list, we have data one after the other in the consecutive locations. But in the graph we have some hierarchical data structure like this way. Here under one node there are so many nodes. This is one hierarchy. From there we have subnodes. From there we can have till subnodes. This is called as an hierarchical structure. Same way for the graph also we are having this is also a hierarchical structure where one particular node consists of more than one branch and there it also have sub branches and so on. So this is also an example of an hierarchical data structure, or we can say it is a non-linear data structure. And let us see the difference between the trees and the graphs. Graph is a non-linear data structure and then it is a collection of vertices, nodes and edges. Each node can have any number of edges. There is no unique node called the root in the graph. But in the tree we have a unique node called the root. And then a cycle can be formed in the graph. Whereas in the trees the cycle cannot be formed. And then the application is it helps to find the shortest path in the networking graph. So similarly for the graph we have these definitions, the differences. Tree is also a non-linear data structure. So non-linear means hierarchical data structure. It is also a collection of nodes and edges. But here The general trees consists of the nodes having any number of child nodes, but in the case of binary trees, every node can have at most two child nodes. For example, there is a root node. If it has two subnodes, that tree is called as a binary tree. As the name implies binary, two values, so the root will have left and the right child. So when the root is having only two child nodes in for all the nodes, then that tree is called as a binary tree. Generally, this any particular node can have any number of child nodes. And the next difference is there is an unique node called root in the trees, whereas there is no unique node such in the graph, but in the case of trees we have a root. That means root is the head from which all the sub nodes will be formed, but there is no such hierarchy in the graph. And in trees, a cycle cannot be formed. If it is the main difference between the graph and the tree is graph can have a cycle, whereas the tree will not have a cycle. Cycle means the closed one. I will see the here. Okay, so the cycle means the closed one. And the next one is the application of this trees and the graph. The trees and the graphs is in the trees we are having the applications like game trees, decision trees, and so on. For example, in the gaming trees we have a red black tree, and then so many type of trees are there where we can have the gaming options, how to move the one coin to the next level, and those moves will be done using the game trees. Also we have decision trees where we are just looking upon if this is the case what has to be done, if that is the case what has to be done. So for any process we need some decisions. These decisions can be made as a tree, because when you have multi-level of decisions, it is easy when you form a decision tree to follow all the decisions carefully. So for such cases we are using the trees as an application where we are having the trees called as decision trees. In the case of graph, we have application called as a shortest path network. For example, if we wanted to find the route of one city to the other city, there will be possibly so many routes from one city to the other city. Now the one such application commonly used in the graph is how to find the shortest path in the particular graph. There may be so many paths, but which is the shortest path? That type of applications can be done using the graphs. I'll show what is the cycle in the graph. You can see this is called as a cycle. So what is the cycle is, it comes to 0 to 1, 1 to 3, 3 to 4, and again goes back to 0. This forms one closed loop. This is called as a cycle. Likewise here 1 to 2, 2 to 3, and 3 to 1. This is also one closed cycle. Likewise 1, 4, 3, one closed cycle. Same way 0, 1, 4. So closed cycles are possible in the case of the graph. But see the tree diagram, you can see here there is no such closed one. One is open from 2 and 3. There is no connection between 2 and 3. So trees will not have any cycle or the closed loop. Here also 2 to 4, then 4 to 8. That's it. Likewise from 2 to 4, then 4 to 9. So we cannot have a branch from 9 to 8. If we have from 9 to 8, that will form a closed loop, which is not the definition of a tree. So a graph can have a cycle. So that's all the differences between the trees and the graphs. Hope it is easy to follow the differences between the graph and the trees, and thanks for watching.